I'm Dinesh Royal from the Department of Artificial Intelligence and Data Science. Let me go through to my project. My project title is Parkinson Disease Progression Prediction using Machine Learning. I doing this process under the guidance of Maitha Nirmala Tennyson ma'am. So, what the introduction of this project is: Parkinson disease is a long-term neurological disorder that affects the normal functioning of the brain. It mainly impacts the motor system, resulting in difficulty in controlling voluntary movements. The disease is caused by the gradual loss of dopamine producing neurons in the brain. Dopamine is essential for transmitting signals that control smooth muscle movements. Due to slow and suppressed symptom development, Parkinson's disease is difficulty to detect earlier. So the background of Parkinson's diseases. So the Parkinson's disease affects both physical movement and neurological coordination. Common motor symptoms include tremors, muscle stiffness, and slowed movement. Non-motor symptoms include speech disorders, sleep problems, and memory issues. The progression rate of this disease varies from person to person. So, Parkinson's disease mostly affects older adults but can occur at younger ages. So, the importance of early detection. Early diagnosis helps in starting treatment before severe neurological damage occurs. So, timely medical intervention can slow down the progression of symptoms. So, early detection improves patient independence and quality of daily life. It allows doctors to monitor disease progression more effectively. So, early diagnosis reduces long-term healthcare and treatment costs. The statement of the problem: Parkinson's disease is often diagnosed only after visible motor symptoms appear. Traditional diagnosis depends heavily on clinically observed and physician experience. Early symptoms are mild or often mistaken from normal aging. So lack of automated diagnostic tools leads to delayed treatment. This is a need for accurate and objective early detection system. The problem definition. The problem is to identify Parkinson's disease at an early stage using data analysis. So machine learning techniques are used to detect patterns in biomedical data. So the system classifies individuals as Parkinson's patients or healthy controls. The approach aims to reduce misdiagnosis and delayed diagnosis. The system supports doctors by providing data-driven predictions. So objectives of this project: to study the symptoms and cases of Parkinson's disease, to analyze biomedical data sets related to Parkinson's patients, to apply machine learning algorithm for early disease detection, to compare the performance of different classifications models, to improve the accuracy and reliability of diagnosis. Thus, what is the scope of the project? The project focuses on early detection using machine learning techniques. Publicly available Parkinson's disease datasets are used for analysis. Supervised learning algorithms are applied for classifications. The system is developed for academic and research purpose. The project can be extended for a clinical decision support systems. The system does not include real-time patient monitoring. Wearing sensor data is not used in this project. Clinical trials and medical validation are not performed. Model performance depends on dataset quality and size. The project is limited to selected machine learning models. We can see this is a literature view. This is an extending approach for Parkinson's disease diagnosis. First one is neurological examination, which takes clinical assessment and patient history. AI-based diagnosis, data analysis and pattern recognition, voice signal analysis, speech permutation and pitch variation, handwritten analysis, spiral test and micrographia, gait and movement analysis, sensor data and motor systems. So existing Parkinson disease methods, these are the methods like current clinical diagnosis, symptom based large system time consuming, and current biomarker research. This is advanced exam not scalable. These methods are proposed machine learning solutions which are biomedical data input and machine learning processing such as feature extraction, model training and classification algorithm. And we can show that the Parkinson disease prediction output has low risk or high risk. It is non-invasive, objective, early stage scalable data driven. We can see this is the medical machine learning data set, which is Parkinson prediction. We can take like patient's ID and their tremor frequency, then change gait speed and voice unstability and voice motor symptoms, and which shows at the end like they have the prediction, they have the Parkinson's, like they are positive if they have the Parkinson predictions. If they are not, it shows the negative. So dataset attributes. So features include fundamental frequency and pitch variations. Jitter and Shinner parameters measures voice instability. Noise to harmonics ratio indicates signal irregularities. Amplitude and frequency measures capture vocal tremor. So each record includes a health status label. So data set pre-processing. Raw data may contain noise and missing values. So missing values are identified or handled approximately. As we may show, raw data as input. There are values. There are some of the methods that can clean these data, like data cleaning, handling missing values, normalizing, stabilize, or normalizing, standardize, and feature extraction. And now is going to feature extraction. Relevant biomedical features are extracted from raw data. Redundant and irrelevant features are removed. Feature selection reduces dimensionality of the dataset. Extraction features represent Parkinson systems effectively. Feature extraction improve classification accuracy. So methodology overview. A system machine learning pipeline is followed. Data is collected and pre-processed initially. Features are extracted and selected carefully. As we can see, data collection, data pre-processing, data extraction, model training, and model testing and performance evaluation. The proposed system architecture. The biomedical data is given as input to the system. Pre-processing model cleans and normalizes the data, like voice signals, handwriting data, gene data. These are taken as inputs, and these data sets are data pre-processing, enters into pre-processing model and do some techniques to clean the data, like cleaning, normalization, feature scalings. After the machine learning classification using techniques like SVM, random forest, and neural networks, and we can predict the final output, like whether is Parkinson detected or not detected. We can see here the system flow diagram. The system starts by loading the dataset. Pre-processing is applied to raw data. So data augmentation, voice, gene, we can see that process, the entire process in this tutorial. So the algorithm used. So what are the algorithms are used in Parkinson disease progression destruction using machine learning? Logistic regression is used as a baseline classifier, and support vector machine handles high dimensional data. So random forest improves accuracy using assembly learning. XG boards exchange prediction using boosting techniques. Algorithms are compared to select the best model. So what is logistic regression? Logistic regression is suitable for binary classification. It predicts probability based on the input features. The model is easy to interrupt and implement. It serves as a baseline for comparison. So training time is relatively fast. We can see this is the machine learning classification for Parkinson diseases. Like these are the Parkinson patients and classified as Parkinson's healthy. So you can see there is a decision boundary between them. This is the one example output. So random forest. Random forest combines multiple decision trees. It reduces overfitting by averaging predictions. The algorithm handles non-linear data effectively. It provides features important informations. Random forest improves overall prediction accuracy. So performance evaluation metrics. So accuracy measures overall prediction correctness. Precision indicates correctness of the positive prediction, and we can see that key matrices are accuracy, precision, recall, and we can see the graph that accuracy is 0.94, receiving operation. And use case diagram. This is a use case diagram for Parkinson disease prediction progression using machine learning. This is a patient and doctor ML based Parkinson detection system, and this is the class diagram which can be shown as dataset pre-processing feature extractions. These are ML models and prediction user interface. This is the sequence data. Patient submit biomedical data system interface. ML pre-processing models doctor. So implementation tools. Python is used for system development. So NumPy supports numerical computations. So Pandas is used for data handling. Scikit-learn provides machine learning algorithms. So Matplotlib is used for result visualization. So import, what are the implementation steps of these project? So import and load the dataset, apply pre-processing technique, extract and select features, train and test machine learning models, analyze and visualize results. So important code segments, code for loading and pre-processing data, feature selection and normalized logic, model training, implementation, prediction generation logic, and visualization of performance matrices. The output screens, dataset visualized output, model training results, prediction classification output, accuracy and performance graphs, comparison charts of algorithms. So these are the results, the performance of the machine learning algorithms of Parkinson disease. like using SVM or random forest regression and gradient boosting and neural networks. We can see the accuracy, algo comparisons between these techniques. The result analysis, performance comparison of all algorithms. So identification of the best performing model. So effectiveness of pre-processing and feature selection, stability of model prediction, overall system reliability. This is the conclusion. Machine learning is effective for early Parkinson detection. The process system provides objective diagnosis supports. AI in healthcare empowering positive outcomes. So future work, integration of deep learning techniques, use of real-time sensor on wearable data. So expansion to larger diverse data sets, deployment as a clinical decision support. So validation with medical professionals. Thank you.